Today, in today's lecture, we will be discussing about the non-traditional machining processes, or you can call them as modern machining processes. In this lecture, I will be discussing about the need for the modern machining processes and their classification. Why we need modern or non-conventional machining methods. There are various reasons for which we need these non-conventional machining processes. In case of materials which are really very hard, such as alloys which are difficult to cut with the conventional machining methods, or they are uneconomical to be cut with or machined with the help of conventional machining systems, then the answer is non-traditional machining processes. Another reason is whenever there is a requirement of complex profiles, you need to cut something very complex shape out of a workpiece, then again it is not possible to do the job with the help of conventional systems, then again the answer is modern machining processes or the non-traditional machining processes. Whenever you need some surface finish which is not achievable with the help of conventional systems, then again the answer is non-traditional machining processes. So that is why we need these non-traditional machining processes. Non-traditional machining processes are basically classified depending upon the type of the energy used to remove the material. It can be a mechanical energy, it can be electrochemical energy, it can be thermal energy, or it can be chemical energy. Depending upon the type of energy used to remove the material, they are classified accordingly. Now, what is non-traditional machining process? Non-traditional machining can be thought of as an operation that do not use shear as a primary source of energy. For example, abrasive water jet operations use mechanical energy, but material is removed by erosion. So no shearing takes place in this case. Another is a group of processes that removes excess material by various techniques involving mechanical, thermal, electrical, or chemical energy, or the combination of these energies, but do not use shear cutting tool, as in the case of conventional cells, are known as modern machining processes or non-conventional machining processes. In case of conventional machining, there is a direct contact between the tool and the workpiece. Whereas in case of non-conventional machining methods, there is no direct contact between the tool and the workpiece, there is no shear force. So this is a reason there is less stresses are induced on the workpiece surface. So now why the non-traditional machining processes? The need to machine newly developed metals and non-metals with special properties that make them difficult or impossible or uneconomical to machine by the conventional machining methods. In those cases, we need these non-traditional machining processes. In some cases, you need to cut some very complex geometries, unusual geometries, which cannot be accomplished with the help of conventional machining systems. Again, the answer is non-conventional machining process. Whenever there is a need to avoid surface damage, the parts which have very low thickness, which are very fragile, they cannot be machined with the conventional systems, then again we need to go for the non-conventional methods. So in case the materials are very hard, with high hardness, high strength, then this operation can only be achieved economically with the help of modern machining processes. If the workpiece is too flexible that it needs supports for cutting or grinding, then again the answer is there is a need for non-conventional machining processes. And as I discussed earlier, if the parts are very complex, or sometimes you need to have some internal profiles, external profiles, small diameter holes, deep holes, then again there are no proper methods in the conventional system, then again you have to move to the modern machining methods. Sometimes surface finish or the tolerances required are so high then that they cannot be achieved with the conventional processes. Again you have to go for the non-conventional methods. And in some cases the temperature rise is so much that it damages the workpiece surface, and and in some cases the requirement is such that we don't want these stresses in the workpiece, then again we need to go for the non-traditional machining processes. So how to classify these non-traditional machining processes? They can be, as I discussed earlier, they can be classified depending upon the type of energy used to remove the material. For example, a mechanical energy, erosion of workpiece material by high velocity stream of abrasives or fluids is a typical form of mechanical action. Example, ultrasonic machining, water jet machining, abrasive jet machining. These are the examples of mechanical energy processes. Then another category is electrical energy processes or electrochemical energy processes. These use electrochemical energy to remove the material. Actually, it is the reverse of electroplating. So the name of the process is electrochemical machining. Then there are also processes which use heat to remove the material. They are categorized in the thermal energy processes. Thermal energy processes usually apply to small portion of the work surface, causing that portion to be removed or by fusion. In these processes, a high localized heat is applied to the workpiece, and as a result of which a high temperature is induced and the material is melted and evaporated. The examples are electrode beam machining, laser beam machining, or you can electron discharge machining. Then the another category is chemical energy processes. In these, a chemical energy is used to remove the material. Chemical agents selectively remove the material from the portions of the workpiece while other portions are protected by a mask. So under this category, the process is chemical milling. So this is how you can classify the non-traditional machining processes depending upon the type of energy they are using. Thank you. Have a nice time. Thanks.